Welcome. In this video, we'll be talking about how to add and subtract fractions with different denominators. This is page 15 in your Alex notes. So what we're going to focus on is actually number 1, which is adding 7/12 plus 7/9. So if you didn't have a chance to watch the video from topic 14, make sure you go ahead and go back and do that, because there are some important points that we're going to revisit in this video. So the first of which is, again, whenever I'm working with fractions or numbers, I want to have a reference. In other words, I want to have an idea of what one whole looks like. And since they don't provide me with a picture in 7/12 and 7/9, what I do is I just drew a rectangle, and if I consider that rectangle in its entirety, that's what I'm considering to be one whole. So if that's the case, what does 7/12 look like? Well, 7/12, what I had to do is take one whole, and I don't want the whole thing. I only want 7 parts out of 12. So I had to break that whole up into 12 parts, and you can see that each part is really small. And you can count them if you want. There are 12 of them there. They're supposed to be equal size, which I didn't do a great job at. And then 7/9 meant I had to take the whole, this whole, and break it into 9 equal-sized pieces, or 9 equal-sized groups. And then I only want 7 of those, so I shaded 7, and I shaded very lightly in each one. But what you can see, hopefully, from this picture is that the pieces in this rectangle, the individual pieces, are bigger than the pieces in this rectangle. Why is that? Well, I had to fit 12 pieces in one whole here, where I only had to fit 9 pieces here. So each piece in this particular rectangle could be a little bigger. Well, what that means is that these, if I look at each little individual piece, they're no longer in each rectangle, they're no longer the same size and same shape. These, again, are each one of these little rectangles are bigger in this rectangle than they are in this one. So why does that matter? Well, again, in math, we only want to add things together that are of the same size and same shape most of the time. So we can't really add pieces in this rectangle with pieces in this rectangle because they're not really the same size. So how do we account for that? What do we do? Well, there's several steps for adding fractions with different denominators. So the first step is to find the least common multiple of 12 and 9. Those are our two denominators. We actually already did this. If you go back to topic number 10, you'll see an example of this along with a video. So I'm going to rush through this step. But because 12 and 9 are relatively small numbers, I'm just going to list the multiples of 12, or at least some of them. 12, 24, 36, and I'm going to stop there. List the multiples of 9, 27, 36, and so on. The point is that 12 and 9, their multiples cross at 36. So my least common multiple is 36. So that's the first step in the process. The second step is I want to find equivalent fractions with my least common denominator, or LCD. So what I mean by that is I'm going to take my original expression, which is 7/12 plus 7/9. And now what I want to do is I want to take 7/12 and somehow turn it into a fraction over 36. And I want to take 7/9 and turn it into some fraction over 36. Now, I don't want to change the value of the fraction, but I do want to somehow transform this fraction form to something over 36 and to something over 36 here. So remember, as long as I multiply the top and the bottom of a fraction by the same number, I haven't changed its value. So if I multiply 12 by 3, I get 36. So what I'm going to do is multiply top and bottom by 3, and 12 times 3 is 36, so that gives me my bottom. 7 times 3 is 21, so that gives me the top. Over here, I'm going to multiply top and bottom by 4 because 9 times 4 gives me 36, and if I do whatever I do to the bottom, I have to do to the top, so I don't change the value of the fraction. 7 times 4 is 28. And now I'm just doing exactly what I did in the last video, which was topic 14. So now all I'm going to do is add these two guys together. Okay, now I've got equal size pieces, so the bottom will be 36. Remember, the denominator doesn't change when I'm adding fractions. But the top, I can now add 21 and 28 together because they represent pieces of the same size and same shape. So 21 and 28 would give me 49. And I could leave my answer like that, or I could write it as a mixed number. So writing it as a mixed number, 36 goes into 49 once, with 13 left over. And so I could write my answer really in either this form or this form. They're equivalent. Okay, your turn. So I want you to try number 2. Pause the video and then restart it when you're ready. So for number 2, the first step again is we want to find a least common denominator, which you should have found is 30. So if I multiply 15 by 2, that gives me 30. So whatever I do to the bottom, I have to do to the top. So if the bottom is 30, that means the top is going to be 10, 5 times 2. Over here, if I multiply top and bottom by 5, 6 times 5 is 30, 1 times 5 is 5. If I now add together the two fractions with the same denominator, we would get 15 over 30. And dividing both top and bottom by 15 would give 1/2 as an answer. Okay, turns out that if we can add fractions of the same or different denominators, the process for subtracting fractions of different denominators is exactly the same. So as an example, let's try number 3. I want you to try this on your own. Pause the video and then restart it after you've given it a try. Okay, here it's a little tricky, but the least common multiple is 93. So that's our least common denominator. And I would have to multiply 31 by 3 and 16 by 3, which would give me 48 over 93. If I multiply 3 by 31, top and bottom, I get 31 over 93. And now I've got common denominators, so the pieces are the same size and shape. I can subtract the numerators, which would give me 17, and the bottom stays the same at 93.